Okay, class, welcome back to my channel. So for today's video, we'll talk about the trigonometric function formula of integration. Okay, so we will again apply the principle of integration, and that means that integration is just the reverse operation of differentiation. Okay, so we already have the differential of the sixth trigonometric function. Now what we will do here is just to apply the principle of integration. Okay, so for example, if you can still remember the derivative of your sine u, derivative of sine u is simply the cosine u du, diba? So applying the principle of integration, integration daw is just the inverse operation of differentiation. So if we integrate cosine u du, then the answer would be sine u. Of course, you have to add the arbitrary constant. Yeah, so this is now your formula for integration of the cosine u du. Yeah, so okay, so if you can still remember, there are 6 trigonometric functions, and all of those have formula for differentiation. And out of those formula, we can derive actually the formula for integration of this trigonometric function. Okay, and this is an example of how we do it. Okay, so what we will do with the other 5 trigonometric function is just to apply the principle of integration so that we can derive the trigonometric function formula of integration. So this is our number 1 formula, the integral of cosine u du, and that is equal to sine u plus c. Okay, we have here the other differential of the other 5 trigonometric functions. So we have here the differential of cosine u, and this is equal to the negative sine u du. Yan. So if we integrate we can derive from this formula the integral of sine u du, which is equal to negative cosine u plus the arbitrary constant. So this is another formula. Yan. So another one, we also have the derivative of the tangent u, and this is equal to secant squared u du. Yeah. So therefore, if we get the integral of your secant squared u du, we'll get tangent u plus c. Yeah. So this is the third formula for the trigonometric function formula. And we also have the derivative of secant u, and this is equal to secant u tangent u du. Yan. So if we integrate your secant u tangent u du, and this is equal to secant u plus the arbitrary constant c. Okay, so this is another formula. And we also have the differential of cotangent u. This is equal to negative cosecant squared u du. And so if we integrate the cosecant squared u, not including this negative sign here, so we have here the integral of cosecant squared u du. This will be equal to negative cotangent u plus the arbitrary constant c. Yan. So this is another formula. Okay, and the last one, we have here the derivative of cosecant u. Okay, so this is simply negative cosecant u cotangent u du. Yan. So applying the principle of integration, being the inverse operation of differentiation, we can therefore say that the integral of the cosecant u cotangent u du is equal to negative cosecant u plus the arbitrary constant c. Yan. So these are the 6 trigonometric function formula of integration derived based on the derivative of the 6 trigonometric function. Okay, so ini nga mga formula, these 6 right here are just derived formula from the 6 trigonometric function. And so that's how you derive it. Now, aside from these formulas, we also have formulas for trigonometric function that are just derived formula by applying the logarithm or the logarithmic function formula of integration. Now, a good example of this is the integral of tangent u du. Now, obviously, out of these 6 derived formulas from the differential of the 6 trigonometric function, itong 6 na to, as you can see, there is no formula for the integral of tangent u du. Diba? Wala naman. Okay, so what you can do here is to manipulate this function. Okay, so that we can apply the logarithmic function formula of integration. So what we can do here is we can express tangent u. We will use yun na nga na naman, yung trigonometric identities. Okay, so you have to know what are these identities. Okay, so you have to be familiar with what are the trigonometric identities. Okay, so we can rewrite these as the integral of sine u over cosine u du. Okay, so you can do this. Okay, now from this form sine u over cosine u, you can use now the logarithmic function formula of integration. So you will use the LF, yan, and your u here will be your cosine u. And if you get the derivative of that, this will be the derivative of cosine u is simply the negative sine u du. Diba? Then you will apply the logarithmic function formula of integration. And the left side of that formula is equal to the integral of du over u. So your du is negative sine u du. And your negative sine u du, yan, all over your u, which is cosine u. Now, obviously, everything can be found on the previous function except for this negative right here. Okay, so what we will do is to introduce a correction factor equal to -1. Yan. And after that, we will now apply the right side of the logarithmic function formula of integration. So this is now equal to the -1 ln of your u. Your u is cosine u. It's right here. So this will be ln of cosine u. Of course, don't forget the arbitrary constant c. So simplifying this further, this will be equal to the negative ln cosine u. Yan, plus c. So this is our answer. So therefore, we can say that the integral of tangent u du is actually equal to negative ln cosine u plus c. Now, this is another formula. So, ang formula na to is just derived. This is the derived formula by applying the logarithmic function formula of integration. So, this is another formula for trigonometric function tangent u. Okay? Now, there is another way to do this. Okay, let me zoom this out. Okay, so we can say that your tangent u du, the integral of tangent u du is simply equal to the negative ln of cosine u plus the arbitrary constant c. Now, there is another way to do this. We can express kasi your integral of tangent u du. Yan. You can express your tangent u du kasi in terms of secant. I mean, you can multiply your tangent u. Okay. Let me show it to you na lang. So this is actually equal to, if we multiply your tangent u, you can multiply this by secant u over secant u. Diba? So the value, secant u over secant u is just equal to 1. So if you multiply it by tangent u, the value of tangent u will not change. So indeed, this quantity right here is just equal to the previous given function, yung integral of tangent u du. Okay, so yan, you can do this also. And if I were to write this one, I'll just write this one. So this is now the integral of tangent u secant u du all over secant u. Yan. Now, you can also apply the logarithmic function formula here. Okay, let me show it to you again. So this is, you will use the logarithmic function formula. So from this one, your u will be your secant u. Yan. And your du will be, the derivative of secant u is secant u tangent u du. Yan. So if you apply the left side of the logarithmic function formula, we will get the integral of ano ba? The integral of du over u, di ba? Your du is secant u tangent u du. So you will write here secant u tangent u du. Yan, all over your u, which is secant u. So we got the same exact function on the previous on the previous line. This is the secant u tangent u du over secant u. Okay, so therefore we do not need to introduce a correction factor. So we can now apply the right side of the logarithmic function formula. Okay, so applying that, this will be equal to ln, diba? Ln of u, and your u is secant u. So this will be ln of secant u. Of course, you have to put the arbitrary constant plus c. Yan. So therefore, we can say that the integral of tangent u du is also equal to ln of secant u. Yan, plus c. So this is another formula of the integral of tangent u du. Yan, so dalawa yung possible result niya, di ba? It could be your integral of tangent u du could be equal to the negative ln of cosine u plus c, or it could be the positive ln of secant u plus c. So there are two solutions for this for this function for tangent u du. Yan. Okay, so there are 8 so far. So walo na nga formula. Walo na nga formula it imo kailangan i-memorize. Okay, so there are 8 formulas so far for the integral of trigonometric function. Okay, now this what we do here, hining integral of tangent u du, you can also apply this whatever we did here. We can also apply that to the other 3 trigonometric function. So for example, the integral of cotangent u, yan, du. So there are no formulas kasi for the integral of cotangent u du. There are no formulas derived from the simple definition of integration being the inverse operation of differentiation. So walang formula for the integral of cotangent u du. Okay. The same with the integral of secant u du. There are no formulas for the integral of secant u also. And also the integral of cosecant u. Yan. So walang formula for these 3. Okay. So what we can do here is we can also apply the same technique that we have used in deriving the formula for the integral of tangent u du. Okay, so you can apply the same technique. But I will not show it to you here. Okay, so I will just write it down immediately, okay? Okay. Now, as you can see, there are ilang bang formula? So we have here 6. We have here 6 plus 2, that is 8 plus 6. So there are 14 formulas so far. That is for trigonometric function formula of integration. So there are 14. Okay, so before I begin with the sample problem, let me reiterate this point first. Okay, now it is important. It will help you if you take note with the pairing of the trigonometric function. Diba dapat alam mo kung ano-ano yung mga nagpi-pair ng mga trigonometric function. Okay, for example, ang cosine pero ito niya associated with sine. Cosine pero ito niya associated with sine. Oh, and your sine naman pero may associated with cosine. So they are parang nagpe-pairing ito nila. Okay, tangent naman is always associated with secant. Yan. And vice versa. Secant is always associated with tangent. Okay? Or another one is your cotangent is always associated with cosecant. And cosecant naman is always associated with cotangent. Okay? Okay ha? So you have to take note with that with that pairing of trigonometric function because it will help you a lot in deducing what formula you will use. Okay? Okay, let's come to some of my examples. I have 3 examples to be discussed today. Okay, let's start with the integral of e raised to theta, second 1 minus e raised to theta, tangent 1 minus e raised to theta d theta. Yan. Okay. Now, obviously, you can apply the formula for the integral of second tangent here. Diba? May formula naman for this combination ng secant tangent. Okay. Let me show it to you. Okay, so we have formula for the combination of secant and tangent, diba? Meron. Okay, so you can directly apply the formula, the trigonometric function formula here. Okay, what we're going to apply here is the integral of your secant u tangent u du, and according to the formula, this is equal to secant u plus the arbitrary constancy. So we will apply this formula. Ito yung i-apply natin. And to do that, you have to identify the value of your u. Diba? So your u here, obviously, is 1 minus e raised to theta. So this is equal to 1 minus e raised to theta. And if you get the derivative of that, this will be equal to the negative e raised to theta d theta. Yan. Okay. So applying the left side of this formula, it's right here. So this will be equal to the integral of secant, your u is 1 minus e raised to theta, tangent your u is 1 minus e raised to theta, and your du, which is equal to the negative e raised to theta d theta. Yan. Okay, so everything can be found in the original given functions except for the negative here. Okay, so wala namang negative on the original given function. So you have to introduce the correction factor, which is negative 1. Okay, so that this quantity will be equal to this one. Okay? Now, after that, you will apply the right side of the formula, secant u plus c. So this is equal to, you have to copy the negatives, the negative 1 because it's outside of the integral, and apply the right side of the trigonometric function formula. That is secant u. And your u is 1 minus e raised to theta. Of course, the arbitrary constant c. Simplifying this further, this will be negative secant 1 minus e raised to theta plus c. Yeah, so this is now your final answer. Yeah, so that's the final answer. So your integral of e raised to theta secant 1 minus e raised to theta tangent 1 minus e raised to theta d theta is actually equal to the negative secant of 1 minus e raised to theta plus c. Okay, now to check, let's check our answer. Yeah, we just need to differentiate our answer, and that is the negative secant of 1 minus e raised to theta plus c. And we'll differentiate our answer. So this will be equal to the negative derivative differential of secant u is secant u tangent u du. Okay, so this will be the negative secant 1 minus e raised to theta tangent 1 minus e raised to theta and du. Your u is 1 minus e raised to theta, so they will have the differential of 1 minus e raised to theta. Yan. Okay, so simplifying this further, this will be the negative of secant 1 minus e raised to theta tangent 1 minus e raised to theta, and your d theta is, du, this will be negative e raised to theta d theta. Yan. So your negative here and this one, it will be, when you multiply them, this will be equal to positive. So this will be secant 1 minus e raised to theta, tangent 1 minus e raised to theta, positive e raised to theta, d theta. Yan. Okay, so let me just rewrite this one. Unahin kong ilagay yung e raised to theta. Secant 1 minus e raised to theta, tangent 1 minus e raised to theta, d theta. Yan. So obviously, this answer right here is exactly the same with the original given function. Okay, so same manera, therefore, our answer is indeed correct. Okay, let me have another example. We have here example problem number 2. Okay, so I have here the integral of sine 2 theta secant theta d theta. Okay. So out of the 14 trigonometric function formula, wala namang formula with a combination of sine secant, di ba? Walang formula for the combination of sine secant. So you cannot directly apply any of the trigonometric function formula of integration. So that's your first problem. Now, another problem I can see here is that the argument of the trigonometric function are not the same. Yung angle nila ay hindi the same. Okay, so the argument for the trigonometric function sine, the argument is 2 theta, and the argument for the secant is theta. So obviously, they are not the same. So there is a problem there because even if there is a formula for sine secant, kahit na may formula for sine secant combination, you cannot still apply the formula because yun nga, their argument or their angles are not the same. So una ni mo nga bubuhaton, you should always find a way na magkapariho yung angle nila. So what you will do is try to manipulate one of the two function, sine or secant. You have to manipulate in such a way na you will arrive at a function wherein the arguments are all the same. Okay? So, that's what you are going to do first. Okay. Now, you might ask, alin ba yung dapat i-manipulate? Yung sine ba or yung secant? Now, it is always easier to manipulate trigonometric function with larger argument. Ita-transform natin siya into a form wherein the argument is lesser than its argument now. Okay? So to answer the question kung alin ba yung i-manipulate, sine or secant ba, i-manipulate is the trigonometric function with larger angle or larger argument. Okay, so manipulate natin yung sine 2 theta. So ang goal natin is to come up with an identity of sine 2 theta wherein all of the argument is theta lang. Okay? So what you can do here is to apply what we call the double angle formula. Okay, you can search this in the internet, the double angle formula. For sine 2 theta, this is actually equal to 2 sine theta cosine theta. Yan. So from this identity kasi ito I believe you are familiar with these trigonometric identities because you are done with trigonometry already. Okay, so you have to be familiar with these identities. So applying this one, we can therefore say this one is actually equal to the integral of your sine 2 theta is just equal to 2 sine theta cosine theta. Yan. And you have here the secant theta d theta. Yeah, so what we did is just apply the double angle formula and we get that sine 2 theta is equal to 2 sine theta cosine theta. Now the new function, as you can see, now, as you can see, is the argument of all the trigonometric function are all the same. Okay? So na-solve mo na ano ni mga problem. The problem where the arguments are not the same. Okay, so na-solve mo na. Okay, so we will try to simplify this function. Because your secant can be expressed in terms of cosine also, 'di ba? So your Another trigonometric identity is that your second theta is equal to 1 over cosine theta. This is another trigonometric identity. I hope you are familiar with this. Okay, so applying this identity, we can therefore write this function is therefore equal to the integral of 2 sine theta cosine theta multiplied by your second is just equal to 1 over cosine theta. And of course, that d theta. Yan. So, from this function, you can cancel out your cosine theta. Diba? So, you will left with, this is equal to the integral of 2 sine theta d theta. Yan. Or you can put your 2 outside of the integral. So, this will be equal to 2 integral of sine theta d theta. Now, you have a formula for the integral of sine theta. Diba? May formula naman for the integral of sine theta. So, you can directly apply that formula. This is equal to, of course, you have to copy 2. The integral of sine theta d theta is simply negative cosine theta, of course, the arbitrary constant c. So simplifying this will be negative 2 cosine theta plus c. Yan. So this will be our final answer. O diba? Halipot lang ay its solution. Okay. So what we did lang naman is manipulate. We just manipulated the function. Okay. And una, the goal was all of the arguments should have the same value. All of the trigonometric functions should have the same argument. So we apply the double angle formula. Then we try to simplify the function. Then we arrive at the integral of sine theta d theta. Then we have a formula naman for the integral of sine theta, di ba? So the result is negative 2 cosine theta plus c. Okay, so let us try to check this. I-check natin yung answer natin if this is indeed correct. Okay, so if we if we differentiate, we'll differentiate our answer. Our answer is negative 2 cosine theta plus c. Yan. This will be equal to, I'll put negative 2 outside of the differential. Differential of cosine theta. Yan. Differential of c kasi is 0. So this is equal to negative 2. Differential of cosine is negative sine. So this is negative sine theta d theta. Okay, so simplifying this will be equal to negative times negative. This is positive 2 sine theta d theta. Now we can stop there, but since we cannot see that this is equal to sine 2 theta second theta d theta. So we have to manipulate this function pa in order for us to arrive with the original given function. Okay? So let us try to do that. What I'm going to do here is I will multiply this by cosine over cosine. So this is equal to 2 sine theta. We'll multiply this by cosine theta over cosine theta. Cosine theta over cosine theta is just equal to 1. And when you multiply this to sine theta, the value of sine theta will not change. Okay, so you can do this also. Of course, the d theta, don't forget. Okay, so rewriting this one, you will have 2 sine theta cosine theta d theta all over cosine theta. Yan. So your 2 sine theta cosine theta, applying the double angle formula, this can be written as sine 2 theta over cosine theta. Yan. Diba? But again, 1 over cosine theta is equal to secant theta. So this can be rewritten as your sine 2 theta secant theta d theta. Yan. So this is now the differential of our answer. Now as you can see, this is exactly the same with the original given function. Diba? Sine 2 theta secant theta d theta. So we have here also sine 2 theta secant theta d theta. So indeed, we confirm that our answer is indeed correct, and that is negative 2 cosine theta plus c. Okay? So that's how you do it. Okay, now, one last example. Let me have another example. Okay, so I have here another example. One last example. We have here the integral of dy all over cosine 2y cotangent 2y. Yan. Now again, you have here a combination of trigonometric function, cosine, cotangent. Now there are no direct formula for the integral of a function that contains cosine, cotangent combination of trigonometric function. Okay, so what you are going to do here is to manipulate this function para makakome up kahin in form, in identity of this given function nga may da formula for the integration of the trigonometric function. Okay, so what I'm going to do is we'll manipulate cotangent 2y. Okay, so the same naman at error argument, so no need to apply the double angle formula. Okay, so what I'm going to do is your cotangent theta kasi, this is actually equal to cosine theta over sine theta. Diba? Okay, so we can use this identity in manipulating the given function. Yan. Okay, so the given function will now be equal to the integral of dy all over your cosine 2y, and your cotangent 2y is just equal to cosine 2y all over sine 2y. Yan. So your sine 2y this sine 2y will go up. So this will be equal to the integral of sine 2y dy all over cosine 2y multiplied by cosine 2y. So dalawa yung cosine 2y. So you can rewrite this as the integral of sine 2y dy all over cosine squared 2y. Yan. Even though walang formula for a sine cosine combination, but you can apply the power formula here, right? You can apply the power formula. So applying the power formula, your n is equal to negative 2 and your u is equal to cosine 2y, and of course your du is equal to derivative of cosine 2y. This is negative sine 2y to dy. Yan. Okay, so we'll apply now the left side of the power formula. So this is equal to the integral of u raised to n du. So your u is cosine 2y raised to n, that is negative 2. Your du is negative sine 2y to dy. Yan. Everything can be seen on this function right here except for the negative and 2. Diba? Your negative and 2 cannot be found in this function. So you have to introduce a correction factor pa. And that is negative 2. I mean negative 1/2. So we'll multiply this by negative 1/2. Yan. And we will apply the right side of the power formula. So this is equal to your negative 1/2 and u raised to n plus 1 over n plus 1. So your u is your cosine 2y n plus 1. Negative 2 plus 1, that is positive, negative 1 pala, negative 1 over n plus 1, negative 2 plus 1, this is negative 1. Yan. Of course, plus the arbitrary constant. This will be negative times negative. Your negative here multiplied by this negative, so that would be positive 1 over 2. So this will be 1 all over 2 cosine 2y. Yan. Of course, yung arbitrary constant plus c. Yan, okay? So this will now be your final answer. This is our final answer. We'll try to check our answer. So we'll get the differential of our answer. The differential of 1 over 2 cosine 2y plus c. And so we'll get the differential of that. So this is equal to, so I'll put 1/2 outside of the differential. Then ang mas mabibilin is the differential of 1 over cosine 2y. Yeah, differential of c is 0. And this is equal to 1/2. Your 1 over cosine is simply secant, the differential of secant 2y. So this is equal to 1/2. Differential of secant is secant 2y, tangent 2y, derivative of 2y. Yan. So simplifying this further, this is 1/2 secant 2y, tangent 2y, derivative of 2y is 2 dy. Yan. So your 2 and 1/2 will cancel out. So you'll be left with secant 2y, tangent 2y, dy. Yan. Your secant 2y, this can be expressed in terms of 1 over cosine. So this is 1 over cosine 2y. Your tangent naman, this can be expressed as sine over cosine. This is sine 2y over cosine 2y. And this is dy. And so this will be, or you can write this as 1 over cosine 2y multiplied by 1 over cosine 2y over sine 2y, right? Yes. We did not violate any mathematical rule here. So this is correct. Okay, so this is equal to 1 over cosine 2y. Your cosine 2y over sine 2y is cotangent. So this is 1 over cotangent 2y dy. So multiplying this, you will get 1 over cosine 2y cotangent 2y dy. Or you can put dy here na lang. So okay, so dy over cosine 2y cotangent 2y. So this is the result of the differential of our answer. And this is actually equal to the original given function. It's right here. So they are, this one pala. So they are the same. Okay, so therefore, indeed, our answer for the example number 3 is correct. And that is, ano ba yun? 1 over 2 cosine 2y plus c. Yan. Okay, so that ends my video for today. Okay, so this is the trigonometric function formula of integration. Okay, thank you for listening. I hope you learned something. And please don't forget to subscribe and hit the notification bell button below to help me grow this channel. Thank you.